Yes, as you said, I've been observing since the space age and the first few satellites that went up at an early telescope. But I've always enjoyed using binoculars, and because they have so many advantages for the beginning astronomer and even for the more advanced astronomer. I put together a little, or actually this was Mark Peter, our fellow member, put together a nice little summary here that I will be using for part of this, and hopefully everybody can see that now. And these are some of this is kind of a detailed background of what we're going to be talking about tonight. And later on, we'll try to send this on, put it out so that people can have copies of this. But so what are the benefits of binoculars? Well, you have this very wide field of view that you don't have with your telescope. People when starting out in astronomy often think about, well, I'm only seeing this much of sky, and binoculars, you're at least seeing this much sky. So it's a good way to learn the sky. And it's also the ultimate grab and go instrument when you're first getting out in the hobby. It shows the sky the way they're really oriented. Beginners in astronomy often get confused when they're using their Newtonian or even their new Catadioptrics optics. The images are reverse twisted or they're backwards, whereas with binoculars, they're the way they are, the way you're looking up in the sky. So it's a great help while you're starting out or even later on, refamiliarizing yourself with the sky. They also can cost a lot less. Some of these binoculars that I have here, I mean, here's a small example. It's probably a $20. And if you want to go all the way up to the Swarovskis and the lights and the others, you can talk about thousands of dollars. But so there's quite a range. And actually, the low to mid-price ones are pretty good nowadays. They're also good for so many other hobbies aspect. I mean, I'm quite into birding and nature in general, so they're a multi-use instrument to have sports and so forth. And so even experienced astronomers love to have them as their sidekick, as sort of their instrument to help as they're going along. And I wanted to talk a little bit specifically about just how useful they are, even if you're an experienced astronomer, amateur astronomer, or even if you're starting out and you're trying to figure out how do I find things in the sky. So what I will do is I think I'll share the screen here with Stellarium, and hopefully everybody can see that. And so this is the great free app Stellarium, one of the great downloadable apps you can get to find your way around the sky. And as an example, if you were out observing and you're trying to find the SA object like 8182, and you found the Big Dipper and you're fine with that, and you think, oh, that's great. And I know somewhere around in here is M8182. With your binoculars, you can zoom in and you can get a view that's going to show you pretty much what's here in the field that will show up in binoculars. Not too many stars, not too few stars. Here's, I always, when I go and find 81 and 82, I usually use these three little asterisms here. So we have a little triangle here, another triangle, another triangle. All these show up beautifully in binoculars. And then right over here is M81 and 82. And you've been right there. You can compare this, by the way, with I'm not sure if I can get the feature here. Yeah, here's a Tellerad view, which is a little narrower. I think this is 3 degrees, if I'm not mistaken. Whereas your binocular view is going to be out here somewhere, anywhere between 5 and 7 degrees. But again, you can get an idea of where you are, how far things are. There's an asterism, there's one, there's another one. Here's M81, 82. So let me get out of this for a second. And I will stop sharing screen. So anyway, that's for those who aren't into apps and online, here's the old-fashioned way to do it. And I have the same thing going on here. There's hopefully without reflections. You can see this is Sky Atlas 2000. There's our Big Dipper. And the nice thing about Sky Atlas 2000 and binoculars is it's roughly the same depth. So binoculars go 8.5 9th magnitude, and that's about what this does. So what you're seeing on your Sky Atlas 2000 or on your app when you're zooming in is very similar to what you're going to get in a good pair of binoculars. With binoculars, you have the other advantage of having both eyes. So you're actually seeing a little bit more. Your brain is actually able to absorb a little bit more information. You can see a little deeper than you would with a finder of the same aperture. So what can we see with binoculars? Well, there's an amazing amount. There's large, bright clusters, Hyades, Pleiades. I love looking at the Perseid Association, if you know that large asterism that's close to the Perseus, the constellation Perseus. And then, of course, you can move on to Cassiopeia and look at the double cluster, the Milky Way star clouds, dark nebula, constellation areas of Sagitta, small constellations like Sagitta, excuse me, Delphinus, and Crux and Lyra. Those are like small constellations. Star colors, excuse me, show up. Variable stars, planetary conjunctions, comets. Going back to 1986 with the Halley's Comet, for those of you still were old enough to remember that, that was one of the great ways of figuring out where is this comet as it was started to come into view. And then, of course, by March of '86, it got pretty bright, so you could see it naked eye, but it was much nicer in binoculars. And then later we had Hyakutake and Hale-Bopp in the 90s. Meteors that are too faint to see is one thing that Mark put on his nice little list here. Of course, you can't consciously look for meteors, but you're often looking at an object with binoculars and you'll see little streaks go by. And of course, satellites and the ISS. The ISS has been in the news a lot lately with SpaceX going up there. And often you'll be out observing it at night, and you'll see something go by, you'll say, is that a plane or is that a satellite? Is that the ISS? The only way you'll really know is to have your binoculars and say, no, it's not a plane. And if it's bright, it's probably the ISS. You can check your Heavens Above app or whatever and verify that. One of the fun things is to watch a spacecraft like SpaceX or the Cosmos or the Russian spacecraft catching up with the ISS on binoculars. And then, of course, there's so many deep gray objects that you can see: globular clusters, emission nebula, planetary nebula, double stars, and many of the M objects. A huge number. Pretty much most of the M objects, I would say some of the faint ones like M77, M74 are a little tough, but most of them, many of them you can see: M31, M42, M8 in M20 in Sagittarius, M6 and M7, the clusters at the tail of Scorpius, M20, one of the nicer globular clusters, I think even nicer than M13. And then things you don't expect, like the North American Nebula. And in really dark skies, I've seen at least the bright arc of the veil in binoculars. So you really have to be in a pretty dark spot to see that. So I want to do a little bit of just a quick history too, because I kind of am interested in the history of optics and history of telescopes. And so not too long, a few years ago, I was on eBay and I saw this and I couldn't resist. This is a 19th century, early 20th century Galilean type field glass, as they used to call them. And I bought this partly for historical optical reasons, but they actually work quite well. Very narrow field. You have an upright view through a concave lens. This is the Galilean system where you don't need any erecting prisms, or there are no prisms in this. But in fact, you can see quite a few things with this. M82, 81, 82, 31, 33, I've seen with this. But your field is about this big. So one of the reasons, in fact, I got these is because there was as an aside, there was a story that said the lookouts on the Titanic lost their binoculars, and it wouldn't have helped anyway because they were so primitive back then. And I said, no, these are actually pretty good night glasses. So you probably could have seen the, I'm pretty sure you could have seen the iceberg with these. But again, very narrow field. And then by the late 19th century, early 20th century, they started developing this. This is a nice British pair of binoculars. Actually, this is World War II. And of course, the idea was to take this and to shorten the light path so you could get higher power and also put in much higher tech oculars or eyepieces. The eyepieces they first started using were usually Kellners, which would give you a 40 to 50 degree field. And those were the standard for quite a while, even up and through like this pair, which is from 70s, I believe. So, but your 45 or 50 degree field, of course, is going to be a lot better than 15 degree or whatever you're getting in your antique. And then as we got into 60s, 70s, and 80s, coatings, or even starting World War II, but coatings became important, and then the anti-glare coatings were added to binoculars in varying levels. And I'll talk a little bit more about coatings later. Let's see. So that's oh yeah, and then of course in modern, most current binoculars, here's a Prism example of some of the higher tech binoculars of current days. Use eyepieces that are much wider field yet, either Urfels or multi-element eyepieces that use 6, 7, 8 elements that give you a very wide view and a much flatter field. So I was going to talk a little bit about the specs that people see when they buy binoculars, and also what you can deduce from some of the specs, you know, the 7 by 50, 10 by 50, and so forth. This, for example, is a 7 by 50. So as most of you know, of course, 7 is the power, 50 is the aperture of the objective lens on this. And of course, the bigger you get, the more light you're gathering, the more stars you see. And then it's a question of what the objects you're looking at, how much power you want, and we'll talk a little bit about power here. So some of the specs that I like to get into are the field of view, apparent field of view, true field of view. People sometimes get confused by that. The true field of view with your binoculars when you're observing is how much sky or how much of your portion of nature are you actually seeing. And often the binoculars that we buy most times will have that listed as 376 feet per 1,000 yards or something similar to that. If I put this here, you'll see this little app here. Sometimes I'll put the degrees as well. And it's a good idea to know when you're observing to figure out how big your field of view is in the sky. And it's, if I go back to the view here where I'm sharing, let's see if I can get you back to the share screen. As I was saying here, it's extremely important to know how much sky you're looking at. When you're looking at binoculars, you're looking at something along the lines of this amount of sky, anywhere from 5, 7, 8, 9 degrees out. So how do you determine that? Well, that's one of the interesting things. There are a couple quick formulas you can use that are very simple to tell. One is to take your feet at 1,000 yards that are often on here, or sometimes it's in meters. And if it's in feet per 1,000 yards, there's one number to remember. That's 52 or 52.4 to be exact. Divide that into this 376 or 400 feet or whatever your feet are there. And then you get your 6 degree, 7 degree, 8 degree, whatever your exact field is. So that is the field of sky that you're seeing. Sometimes it'll be if it's in meters, you don't divide by 52, you divide by 16 because you're talking about a different dimension there. So I'll give you an example here. If you had 400 feet at divide by 52.4, you get 7.63 degrees, for example. So the second thing that people get confused about as far as field is the apparent field of view. And the apparent field of view is pretty much what it looks like when you're looking through the eyepiece. Is your eye see something that looks like this from looking from here, like you're looking around, or is it down here up to here? And you're talking about differences between about 4 and 5 degrees and 7 or 8 degrees. So the way you can figure out your apparent field of view is to take your power and multiply it by the magnification, multiply that by your real field of view, and you'll get your apparent field of view. I have a pair here that's actually being very nice. These are some Celestron Ultimas I got a few years ago. Here they actually have both figures on there. But if you take, this one says field of view 6.6 degrees, 10 power, and multiply it by 10, I get 66 degrees. So 66 degrees is what my eye's seeing in the eyepiece, seeing this pretty wide area. A lot of the older standard binoculars with the Urfel eyepieces often have a apparent view of around 45 to 50 degrees. Another important aspect is the exit pupil, and this term exit pupil is actually exactly what it sounds like. It's the light pencil, that beam of light that's coming out of your eyepiece matches the pupil of your eye, or is bigger or smaller than that. Most younger folks have pupils that are 7 to 8 degrees. A lot of us older folks, we're lucky if we get 4 or 5 degrees, depend. But obviously, if your exit pupil is pretty close to what the maximum width of your pupil is that's coming out of the binoculars, you're getting the brightest view possible. And that's very useful when you're using these at night to know about, to have that capability of seeing as bright a field as you can. But it's not always the best thing that you need to have in astronomy viewing. And as I mentioned, to find that, you take your power, in this case, or your aperture, on this one, 50 millimeters. And let me see, you've got 7 power, and this has got 7.71 degrees or 7.71 millimeter exit pupil. So that's about as bright as it'll get. The disadvantage for astronomy is of having the full size of your pupil match the exit pupil from your binoculars is that the brightness also accounts for the entire sky. So if the sky there's a little bit of light pollution, even a moderate amount of light pollution, you're not only brightening up the object that you're looking, that nebula or galaxy, you're actually brightening up the sky background as well. So and sometimes it's better to have a little more power and a little smaller exit pupil, and seeming a little dimmer image, but a little better contrast. And the other reason you might want to do that and not have your lower power here is to make your objects a little bigger. So this, for example, is a 7 power 750. These are typical night glasses. If you're looking for a smaller galaxy or nebula, it could be confused as just a little small asterism or something. It's difficult to tell what you're looking at. And just like with a telescope, sometimes image scale is a lot more important. A little while back, Brad Haney gave us a really nice talk about night vision and your, what is it? I think scotopic vision, not to remember the exact word for that. Is that correct, Brad? And so your night vision resolution isn't as good as your day vision. And so in some ways, it's more important to have image size and scale than it is brightness. So in that case, if I take my 10 by 42s here, these are 10 power for 42 degree, which means that my exit pupil is only 4.2 degrees. But often I can see more with these when I'm looking for M81, M82, or some other smaller M objects than I can with something with bigger aperture, because the image is the overall sky is a little darker and the image is bigger. Same applies for telescopes, by the way, if you're observing with telescopes. And you've got to find that nice medium power. If you use your lowest power with your biggest exit pupil, you're brightening the sky as well as the object. So I often find for galaxies a nice medium power, the 2-3 millimeter exit pupil works very well. So that's exit pupil. I wanted to get into some of the different sizes and what they're useful for. Got everything here from, here's some of my birding binoculars. These are 21 millimeter. And I've got medium-sized binoculars, and I even have my monster, not really monster, these are only 70 millimeter. They go a lot bigger than that. But so the weight and what you're using for is what's so important here. Weight can be a factor. So small binoculars that I use for birding like these, or these, for example, are going to be the best thing you'd want. And you're talking about daylight then. For astronomy, anything from medium to large is what you really want. So you're talking 40 to 50 millimeter lenses, sometimes even up to 60. You consider these are hand holdable. So these you can still hold steady at a certain rate and not have the movement of your hands messing up your image too much. The higher the power you go, the more likely you're wanting to put those on a tripod or something. And then you go all the way up to, as I said, the 70 millimeter and up, 80 millimeter, 100 millimeter. These can be handheld, but usually you can get better at it, but you find you're figuring out different ways to hold here and try to balance. And you're also talking about a little more magnification. These are 15 by 70s, and they're often up to about 20. And then you're talking about your objects dancing around in the sky. There aren't image stabilized binoculars, which I don't have to have, and they tend to be in somewhat small to medium aperture because of the costs involved. I've looked through some 30, 35 millimeters versions. Can't remember the maker at the time. Maybe somebody can mention that. But they work pretty well. It's, of course, no better than having on a tripod or something. But the cost is considerable, so you're more likely to see those in 30 to 40 millimeter at most. Even the jump from 30 to 40 millimeter increases the cost quite a bit. And then I didn't talk too much about the design when I was talking about the advancement over time of binoculars, the two basic types, of course. These are the Poro prism types with the prisms in kind of a zigzag pattern. This, of course, was, as I said, historically done so that you were able to drastically reduce the size of the binocular and get the same power and use the better eyepieces. But a lot of nature folks, birders and wildlife people like the roof prisms better. This pair here has a very wide field, has good eye relief, which I'll talk about here in a second too. And here the prisms are kind of in a zigzag pattern, straight line. So let me go on to here. Oh, one of the key aspects to also look for when you're buying binoculars or getting them used is what's known as eye relief. And eye relief is simply the distance between your eyepiece and your eye. And of course, if you have glasses like I do, that's a very important aspect. Many of the modern binoculars have adjustable eye cups, so that does enable you to get closer to your eyepiece. And if you're not wearing glasses, you'll probably want these out as much as possible. The eye relief, if you're for a lot of new binoculars, to have it far enough back should be 16, 18 millimeters and up. If you see binoculars on sale and they're saying somewhere between 10, 11 millimeters, that means you're probably going to have to do this. You're going to have to take your glasses off. Or if you have contacts, you'll be fine. But that's eye relief. One of the things about using, speaking of glasses and any kind of optical correction, is that if your vision, whether you're farsighted or nearsighted, is such that your astigmatism isn't too bad, you can actually take these off and focus for your maximum. If your astigmatism is pretty severe, then you're still going to want to use this with your glasses on. But I've had some of my older binoculars that I still use that don't have as much eye relief, or they have eye cups that aren't as adjustable. Then you can get close enough to get the full field of the binoculars. Even if I have some astigmatism, but it doesn't bother me too much. Whereas I know other folks if you take your glasses off, by the way, here's a test is to do this and say, oh my gosh, it's making all kinds of distorted patterns. That's a little indication that your astigmatism is a little is pretty severe. If you do that and you don't see a huge change, kind of a funny mirror kind of effect, you probably don't have, your astigmatism probably isn't too bad, and you can just take your glasses off and refocus. So some of the features that we want to look at here, Mark came up with a nice list, and I won't mention all of these, but waterproofing. They have some of the better birding, nature binoculars in particular. These are ones that people take out for birding and nature and hunting. Waterproofing, nitrogen purge means that they can get wet. You can be out in humid weather, or if you're observing in astronomy and you have a lot of dew, you're less likely to get any moisture inside the binocular. As I mentioned, good eye relief, field flattening features. Some of the newest binoculars that are out now, either by the use of the optics of the eyepiece or internal field flatteners, are able to give you a sharper image all the way across the field. Normally with traditional binoculars, you tend to be concentrating on the center of the field, but if you look towards the edges of the field, you'll notice a star field, and some of the stars will start to exhibit coma, get a little pointed here and there. So you tend not to notice it when you're looking right at a specific object or a small nebula or galaxy. Even on the moon, it's not too bad. It's not as bad as in a telescope. But as I say, some of the new, even medium price and up binoculars have correction that keeps that image sharp almost all the way to the edge. Another first thing to always check, depending on how far apart your eyes are, is the interocular distance. How much can you do that? And I've known people that sometimes are almost at the edge, that they come all the way in or they come all the way out. And I guess you'd have to be pretty wide to be all the way out. But make sure you can actually look through them. Oh, let's see. Whether they have a socket for a tripod. Now this one doesn't, but I'm sure usually you'll have something that's right in the center of your field, and this will unscrew. And this is usually a standard quarter 20 screw, which will go on any tripod mount. And most of the types of binoculars that people use in astronomy have that, so you're ready to go with a mount. The coatings is a key feature. Starting with the older binoculars, like this pair, it'll usually say coated optics, and all coated optics means when they put coats, this anti-reflection coating, which is blue or green, sometimes yellow, only on certain surfaces of your binocular and certain surfaces of some of the surfaces of the eyepiece. One way you can tell that, if you're buying used or you have looking in a store, is to hold these up to a light, look at the reflection, and if you see both a blue reflection and a neutral whitish reflection, that means not all surfaces have been coated. And over the years, they went into more and more. They went from coated to fully coated to multi-coated to fully multi-coated. And fortunately, most new binoculars now that you'll get like these are fully multi-coated. And when you look, try the same trick that I mentioned, take a light, look in the objective, or look at the glass on the other end, look for the reflection and see if you're seeing a dim bluish greenish image or you're seeing a whitish image. Most have coatings on just about all the surfaces. Over the years, they also would say put in better glass in the prisms. It used to be BK7 glass, and then it went to BK4 glass. BK4 glass is the superior as far as transparency. Phase coatings is another thing to look for. That's something that on the roof prism binoculars is required because the configuration of the prisms here is such that the prisms in here give you an image coming through that's out of phase just because of the way the reflections are hitting. And it's a little bit like taking your Polaroid glasses and holding up to a reflection in a pond, and you turn it and you see, oh, it's blocking out some of the light. Well, you don't want to block out the light on your binoculars. So there are special coatings that are put on the better quality roof prisms that compensate for that and allow the light, the transparency, and the passage of the light to be complete from beginning to end without that out of phase situation. Let's see, as I mentioned, diopter adjustment, filters, some of the better, like these binoculars here. This one does. Let's see if I can find that. You can actually screw filters onto some of the front or the back. This one doesn't allow that, but some of the big ones do. One thing I wanted to say in terms of all these little features like the coatings and the quality of the eyepieces is that it's gotten to the point that many of the even mid-price and up binoculars have incorporated a lot of the features that were in binoculars that were only higher priced before. Used to be you'd buy a pair of Swarovskis or lights to get the field flattening, to get every coated, surface coated, for the waterproofing, nitrogen purging, all the rest. And now when you go out and buy new, this pair I think was something in the 150 to 200 range. And it's got wide field that has a very high-end or sophisticated eyepiece design. It's got good eye relief, so I can have my glasses on and see it. Fully multi-coated, and it's doing most of what some of those $2,000 binoculars will do. The $2,000 binoculars and up will sometimes have even better cross the field flattening, and I believe some of them will also give you lifetime warranties, and you can take your $2,000 Swarovskis, if you drop them, get them out of collimation and send them back and they'll fix them. But don't quote me on that. I haven't had a pair of Swarovskis or lights lately to see if that really works. Let's see. I wanted to say a little bit. There aren't too many more points I wanted to mention on the general times. Oh yeah, adjustable eye cups. I did mention that a little bit. On some of the older binoculars, the least if you could adjust it, you'd have at least a fold down cup, which is fine. A lot of the newer ones that do have these the screw-based type that are a little easier to adjust more precisely. Things to avoid, yeah. Mark also put on his list some other things here like zoom binoculars, which are often they tend to have narrower fields of view. Some of the coatings that are ruby or yellow or often on binoculars aren't the best quality. Another aspect that I was going to mention is you don't see too many now. You used to see binoculars in stores that said fixed focus. You don't have to focus them. And really that meant they're focused at some kind of infinity. And they're not very good for astronomy or for most things, I would say. But you don't see too many of those. Let's see if I want to. Yeah, I was going to also talk a little bit about checking, especially used, sometimes new, but used binoculars to test them out to make sure that you're getting a pair that's decent, not out of collimation, doesn't have other defects. Checking collimation is one of the key things to do. If you have an older pair of binoculars or you're thinking about buying someone, there are several ways to check that. One is to find a distant object, see when you look through, and does it look okay? Are your eyes straining and so forth? That's kind of a rough test. One of the more accurate ways is to find some level line, like a power line at a great distance, and focus in on the power line with both eyes, and then see if blink your eyes and see if you're getting this or you're getting this in the power line, and that's going to tell you, oh, I think these are out of collimation. Now, if it's a better pair, you can have those repaired. Sometimes you can fix simple problems. I had a pair once where, not this one, but it turned out this front barrel was a little off, and if I twisted it back into shape, it went back into collimation. But more often it's related to the prisms, and I know there are some folks in the club who know the trick of which prism screw to turn. I haven't tried that, but maybe later in the chat somebody can point that out. Generally, I don't recommend that. There are companies, especially in Florida and places, that advertise that they will do a complete overhaul, recollimation, and so forth. And if you have more expensive binoculars, that could be useful. I don't know that the prices are always real high. I've thought about that with a couple pair I had, but haven't tried it. So let's see. Oh yeah, can you get a good focus? So I've had binoculars, even new ones, where I tried to focus. I went all the way in, all the way out, maybe with my glasses I couldn't, but without my glasses I could get a focus, or vice versa. You want to make sure that you can get a focus, that the travel in and the travel out is going to be sufficient, that you can actually focus them. Looking for defects in used binoculars, what you'll sometimes get is not just dirt, but even fungus or something that grows inside the binocular, which is kind of hard to get out unless you're doing a major overhaul. They could be on the prisms, they could be on the eyepieces. One way to check is to not look through the way you would normally would, but to look through the other end at a bright light and look at every aspect of that way you can see if something's on the prisms or on the back of the eyepiece, even on the back of the objective lens. And over time, many older binoculars will tend to get that, especially if they've been kept in a damp basement or something like that. So I think I don't see too many other points I want to get to here on my list. As I said, most of these hints and the background information I'll put on this document that I mentioned before, and we'll make that accessible on this either through one of the forums here. And I think pretty much that's what I have for now. If people have questions that I can answer or go into detail on any of the points. So that's about it.
Hi everybody, my name is Mark Peter, and I'm presenting the second half of Binoculars for Astronomy. So my co-presenter, Willkie Cirker, has already told you about how to choose a pair of binoculars. And so I'm going to talk about how to use your binoculars for astronomy. So normally I would be giving this presentation in person, but with the current pandemic situation, we're doing everything virtually now. So please bear with me. So what I'm going to talk about first are some accessories that you can use with your binoculars. And I'm going to go through, and some of the most important accessories probably came with your binoculars. So to demonstrate, I'm using my trusty Fujinon 10x50 binoculars. So if you listen to Willkie's talk, you will know what that means when I say 10x50, so 10 power magnification and 50 millimeter objectives. So the accessories that probably came with your binoculars are a rain guard. So that is the part that covers the eyepieces of your binoculars. And it's highly advisable to keep these engaged when you're not using them so that you don't collect dust. But generally you will not be observing in the rain for astronomy. So hopefully you won't need those too much. Also important are the objective caps. And the main thing with the caps is just to, when you're not using the binoculars, always keep them capped, because you'll keep the lenses clean and keep the dust off them, and you won't have to clean them as often. These have coatings, and you don't want to have to clean them any more than is necessary. When you're outside, and especially if it's kind of cold outside, it's a good thing to cap them before you come back inside. Because what's going to happen is they're going to want to condense, and you're going to get moisture that's going to condense on the cold objective lenses when you bring them inside. If you forget to do that, though, you can take like a big Ziploc bag and just place the binoculars inside to keep the dust off them. Just don't zip the bag, because you want the binoculars to dry out fully before you store them. So these are some of the things that probably came with your binoculars. Now, if you buy a modern pair of binoculars, they might come with a nice neck strap. I like to have a nice comfortable neck strap. You can always buy, if you have, especially if you're buying some of those vintage binoculars that Willkie showed us, they might come with a leather neck strap like this that will just bite into your neck and not be very satisfactory. So the first thing I would do with a pair of binoculars like this is replace the neck strap. I highly advise that you use the neck strap, especially if you're using handheld binoculars. So it's very easy to forget what you're doing in the dark and let the binoculars fall. Then you may have your two barrels out of alignment. That would be really bad. So I would use the neck strap when you're hand holding binoculars. If you're doing outreach, I highly advise that you ask whomever is going to be looking through your binoculars to put on the neck strap. Because again, they'll prevent a sad event from happening. Some other nice accessories for binoculars are something to keep the dew off of them. And you can use the same kind of dew straps that you would use for your telescope, but those of course require a battery and a controller and the dew straps. And one of the nice things about binoculars is that they're portable, and you don't want to have to be lugging a whole bunch of equipment around with you. So one thing you can do is put the binoculars, if you're wearing a fleece to keep warm, you can actually just put them under your coat or fleece. Just make sure there aren't any sharp zippers or anything that are going to scratch your binoculars. And if you just keep a little bit of body heat and keep them above the ambient temperature, then when you pull them out to use them, they won't fog up. Very important in these humid Ohio summer nights to have some kind of dew control for your binoculars. Now, I have a little portable solution that I found works very well. So, and that is using your chemical hand warmers. So you can actually take some of these out and you can put them in a sock or something, and then you can actually, rubber band them. You can put them around your, maybe one around your objective lenses, and maybe one up closer to the eyepieces. A sock works. There is a handy dandy little contraption called a lens muff, and some enterprising photographer developed this, and it actually has space for up to 3 hand warmers, so that you just you just get the hand warmers out, you shake them to activate them, you put them in the 3 little pockets, and then this has some Velcro, and you can actually wrap it around your lens, and you can put one around for the objective lenses, and if you have large binoculars, you might consider putting one on each of the objectives. So these actually will last all night, usually, or at least most of the night, and will keep the dew off your binoculars. So these also work really well if you're doing some astrophotography to keep your lens from fogging up. So I really like these little lens muffs, but again, you can kind of jerry-rig something out of a sock as well. With any astronomy session, of course, 2 of your accessories are going to be some insect repellent. Some people like to use eucalyptus or something that's a little more natural. This is DEET. If you do get insect repellent, I recommend not getting any more than 25% DEET. And the reason is that if you get higher percentages of DEET, it's very corrosive to your lens coatings and the rubber armor on your binoculars. Matter of fact, whenever I use something with DEET in it, I also take some hand wipes and I wipe off the palms of my hands. Because again, if you have something like a rubber coated binocular, so this one is got a rubber armor on it, and this has some advantages mainly for marine use. So because these are a little bit easier to grip with wet hands, so you will find some very good binoculars that have this rubber coating on it. But this rubber coating will become dissolved if you have DEET on your hands. Also, the DEET is not good for the coatings, the anti-reflective coatings that are on your eyepieces and objective lenses. Now, you can get some, well, I'm going to talk in a second, in a little bit, I'm going to talk about mounting binoculars. And you can see behind me that there's some binoculars that are mounted in various ways. But in order to mount the binocular, you're going to need an L bracket. So an L bracket may have come with your binoculars. So if you have a pair of, say, Celestron Skymasters, like the ones that way behind me, they came with a little plastic L bracket that came in the box with the binocular, and you want to probably trade that or give it away. Those plastic ones, unfortunately, have a lot of play in them, and they're very shaky. They're better than nothing, but I highly recommend getting a metal L bracket. You can get these from a company called Oberwerk that sells large binoculars, and they're based in Dayton. They're local. Kevin, the owner, is a great guy to work with. You can get these for about $8 to $10, and this is a cast metal version, and it's a lot. There's a lot less shake in it, so it'll give you a steadier view. So you'll need an L bracket. Now, most binoculars will have a socket that you're going to screw this this L bracket in. So this is a standard 1/4 20 screw, but a lot of people don't realize that they have a place on their binocular to screw these in, and a lot of times the socket is actually hidden. So normally it's going to be right here near the hinge, on the front of the hinge of the binocular, and it's going to be hidden by a little cap. So all you have to do is unscrew this little cap. Now some people like to take this little cap and hide it in a safe place, because otherwise you're going to lose it, and then when you go to resell the binocular you might want to have it. So I sometimes will remove these and label which binocular they go to and just keep it in a safe place. So then you've got your exposed socket, and you just screw it in, and then you can attach the binocular on the bottom of the L bracket. There's a place to put a tripod plate. So you can put your tripod plate, and then you can actually hook this onto your tripod or monopod, which I'll talk about in a minute. This is a very important accessory. I like to have a couple of these L brackets so that I can, if I'm using multiple pair of binocular, I can actually switch, and I don't have to necessarily screw this in each time. I have multiple of these. Of course, you're going to need your red light flashlight for reading your star charts. If you don't have a red light flashlight, and I like a dimmable one, so this one is just one you can get like from Orion telescopes, and you can make it dim. But if you don't have one, in a pinch, you can use some brake light repair tape that you can get from Walmart, and you can actually put this over a white light flashlight, and if you put a couple layers of it, it'll work as a ersatz red light. Now you can get some fancy kind of accessories for your binoculars. So for example, these I made for the total solar eclipse. So the pair of large binoculars on the parallelogram mount behind me are some Fujinon Polaris 16 by 70s. So they're 16 power, 70 millimeter objectives. And I actually watched the total solar eclipse, the great total solar eclipse, a couple years ago in 2017, using that pair of binoculars. Now, in the partial phase of the eclipse, you have to have solar filters, and they have to be on the objective end, so not the eyepiece end, but on the end that's farthest away from you. That's very important. Never on the eyepiece end, because you want to filter the light before it comes through the binocular. So these are some Bader Astro Solar filters that I made, and these I happened to find a lid that was fit snugly around my the objectives of my Fujinons, and it turns out that the right size was a Haagen-Dazs ice cream pint lid. So I dutifully ate multiple pints of Haagen-Dazs ice cream I also recommend Grader's ice cream. Do we get paid for endorsements? No, I don't think so. Anyway, so I made a pair of objective filters to watch the partial eclipse. And then once it was in total eclipse, I removed the filters because when the sun is completely eclipsed by the moon, and it has to be completely 100% covered, then you can actually observe the sun without the filters. And the view through those 16 by 70s was a memorable one that I'll never forget. You also have to be very careful to, before the sun reappears, to look away, to move your binocular out of the way so nobody can accidentally look through it until you replace the solar filters. Now, if you want to not have to worry so much about safety, you can actually buy some binoculars that are designed, they have built-in solar filters. So this one would not be any good for the total part of the eclipse, but for the partial phases, it actually has filters built in the objective end here. And so these binoculars are completely useless except for looking at the sun. Although you can kind of see clouds passing when they get close to the sun and things. But I've used these to watch the transit of Venus and a transit of Mercury. Mercury was teeny tiny in these because they're only, I think these are 10 times magnification. And so it's barely adequate to show Mercury. It was plenty to show Venus, but you'll have to wait another 100 years or so to see that. So if you eat well, maybe exercise. So let's see, oh yes, so you can get some really fancy kind of filters. So my Fujinons actually have filters. These can screw in the front because you don't have anything dangerous like sunlight coming through. These are moon filters, or neutral density filters, that actually screw into the eyepieces. Unfortunately, you have to be very careful not to smudge these when you're trying to look in the. So, in some ways, they're not super duper practical, and they're also kind of a pain to screw in. I'm not sure I would buy these again, but there is a simpler solution. You can just put on a pair of sunglasses and view through these. So people might wonder what you're doing wearing your sunglasses at night, but actually if you're looking at the full moon through a pair of binoculars, it's going to be pretty bright. So these are my inexpensive moon filters. So finally, well, okay, I forgot about these. So there's another way to kind of keep the dew off your binoculars, and that is the same you do for your telescope. You use a dew shield. So for binoculars, you can actually make dew shields, and I use some little foamies that I found at Michael's Crafts or Joann's, and some strips of Velcro. And basically these, you just basically wrap around. It's going to be hard to hold it and do this at the same time, but it's easier to do if you're setting it down on a flat surface. But basically you just wrap them around, and you can see that they look ridiculously long. But you actually want a dew shield that's about 4 times the diameter of your objective lenses. And the way it works, you're basically losing heat to radiative cooling, but these actually restrict your view of the sky. So you're actually looking at a little bit less sky, and so you're going to lose a lot less heat to that radiative cooling. And So I recommend having these on there and using maybe something like a dew heater or the lens muff solution that I showed you previously. But these you can make yourself for any size binocular that you happen to have. So another nice little accessory to have is a cleaning kit. And what I have for my cleaning kit is first of all is a lens air blower. So this is basically what you want to use first. So you want to if you think you need to clean a lens, is first of all you want to make sure there isn't any dust, any hard dust particles. So you're gonna give it a good, blow all the dust off. If you have quartz in your dust, the quartz will be harder than the glass and can actually scratch it when you rub a cloth over it. So you want to first try to get any dust particles off. Now sometimes you'll get these stubborn particles of dust, and I recommend also being careful about observing on, like, say, a gravel road when a car goes by and stirs up the dust. That's good. Probably not the best place to observe. But if you get some stubborn dust, you can flick it using like a camel's hair brush or other brush made for optical equipment. Make sure you have a nice clean brush, and you from the center out, you just kind of flick. You don't want to smear, you just want to kind of flick it off. And then finally, my last stage is to take like a soft, microfiber like lens cloth, and I'll basically breathe on it, and then you kind of just very gently are going to wipe from the center outward. And it's important, don't try to wipe around the edges, because if there's any dust or anything on those edges, again, you could cause scratches. So that some people basically clean their optics very, very seldom. I, on the other hand, like to clean my optics after each night of use. So what I usually do is, I'm usually tired when I come home, so I don't try to do the cleaning then. So I just wait till the next day when I'm well rested and patient, and then I get some natural light and I can really see whether they need to be cleaned. If they don't, I don't clean them. But if there's like a fingerprint on there, you want to remove that oil, because that oil can damage the coatings on your lenses. So if there's a fingerprint on there, I like to remove it. And my theory is that if you keep the lenses really, really clean, then you don't have to do any heavy cleaning, which is usually where you're going to end up damaging your coating or scratching your lenses. So I like to clean them after each use, and then I store them. So speaking of which, that is another important accessory that I almost forgot. So this is something that may have come with your binocular, is a soft storage case. So this is the one that came with the Fujinons I was showing you, and it might have a little accessory pocket to put a cleaning cloth. Now, this is good if you have a really rugged pair of binoculars, and that's one of the advantages of a quality pair like the Fujinons, is that they're much less likely, if you bounce them accidentally on something, they're much less likely to lose their collimation, or alignment to be technically correct. So much better is a hard case, and these can be custom, you can custom cut foam, and to put your, put your binoculars inside. These are actually custom cut for the pair that is, that side, the 15x70s on the tripod there. This one, the latch is not as good. What I really recommend are Pelican style cases. Now, Pelican cases, as you know, if you price them, are very expensive. But if you go to like a harbor freight store, they have some knockoff Pelican cases that are very, very rugged and a fraction of the price. And those make great binocular cases. And a lot of times they already come with some pluck foam that you can basically customize without having to custom cut the foam. You just kind of pluck out the squares that you need. And of course, if you actually want to know what you're looking at, you might want to have some kind of observing guide. So a lot of people use fancy electronic things on your iPad or your cell phone. I'm a little bit more old-fashioned. I actually like printed star atlases. So in the spirit of going portable, I really like this Sky and Telescope's Pocket Sky Atlas. This is a classic. If you don't own it, just go out and buy one. You can get them for about $20. And this is got enough detail that if you're just learning the sky, it's going to have a lot of the objects that are visible in binoculars. So it matches well to the capability of the binocular. Now, if you're a little bit nearsighted, or if you're of a certain age and require bifocals, as I do, you might want to go with the slightly larger. This is the Pocket Sky Atlas for old people, or I think they call it the Jumbo edition of Pocket Sky Atlas. So you might not need your bifocals if you're using this one. It's basically the same atlas, it's just printed bigger. So I really like this atlas. If you're looking at the moon, Sky and Telescope has a field map of the moon. Just don't get the mirror reversed one, because everything would be backwards. And remember, when you're viewing through binoculars, one of the advantages is that you see it as your eyes see it. So make sure you get the right version. But you know, this is a great, and it's laminated, so you don't have to worry about it getting wet. So this is kind of great for looking at the moon. And the moon is a great object for binoculars. Now I could probably do a whole lecture on printed star atlases. I bought a whole bunch of them because I was just looking for the perfect star atlas. And in general, you know, some were better for some purposes, some were deeper, you know, some would show more detail, some were too cluttered. And then I found the perfect star atlas. So I'm going to give a plug for the Stellarium Deep Sky Atlas. This is the field edition. It's actually got waterproof pages. And if you buy this atlas, you can stop looking. Just, you know, it's expensive. But I love this atlas. And one of the nice things about it is that the brighter an object is, the easier it is to see, the bolder it is the print for its label. And so you can look through here and you can get a real feel for, you know, the ability of your binoculars to see various objects under different sky brightnesses. And so if I go with the brightest objects that are depicted here, I know I can find all of those pretty much with my 16 by 70 Fujinons. So I don't bother looking for the objects that are too dim for them to see. So I love this. This again is the Stellarium Deep Sky Atlas Field Edition. Okay, so I think I've covered accessories pretty well. So now I want to talk a little bit more about what you need to do when you unpack your binoculars and you want to actually use them. So first thing you're going to have to do, binoculars are highly personal instruments. You're going to have to make some adjustments. So the first thing you're going to need to do is adjust for the interpupillary distance. So some people's eyes are rather, close together. Some people's are farther apart. Generally, that's really easy to do. You just flex the binoculars, right, to adjust. However, if you have very narrow interpupillary distance, you may want to make sure before you buy the binocular that they'll actually adjust narrow enough for you. Now, contrary to the way binoculars are portrayed in movies, when you look through them, you should not see two separate circles. You should actually see one circle, unless you're viewing objects that are very, very close. Then you will see some overlap between the circles. But basically, you want to merge the objects, and it helps if you take these off. Basically, you want to, if you're looking at a distant object, you want to adjust this until you get one nice, well-illuminated circle. So that's adjusting the interpupillary distance. The next thing you may need to adjust are the eye cups. If you are, wearing your sunglasses at night, or if you actually happen to wear eyeglasses to see, then what you're going to do is, if you have rubber eye cups, you can actually, on a lot of pair of these binoculars, you can actually fold them down. And what this does is it allows you to get closer so that you can actually take in the entire field of view. If you're not close enough, you won't see the edges of the field of view. And I like to be able to see the whole field of view when I'm viewing. You do have to be careful because glasses, are hard, and these surfaces are hard, but they have coatings on them that your glasses don't scratch the coatings or scratch the glass on your eyepieces of the binocular. So I'm sometimes a little careful. I only give them to people that I trust who are eyeglass wearers because they are going to have to get in pretty close. This is where having good eye relief is important. But adjusting those eye cups is helpful. Now, some binoculars actually have click stop adjustments, and you just rotate to a different click stop, and you can make these shields basically shorter, so you can get in closer. So that's for people who wear eyeglasses, and then you need to adjust the focus, and this is important. I actually spend several minutes. I mean, sometimes I'll spend like 5 or 10 minutes focusing my binoculars. But once I get them focused, if you have individual focus, which a lot of the binoculars designed for astronomy, the Poro Prism type, have individual focus. And these tend to stay good for like the whole night, pretty much. But I'll spend a lot of time focusing. The way I do it, since these are individual focus, you can focus each eye separately. And I'll start with a bright star, something I can see easily, and I'll get a sharp focus in each. And then I'll go and I'll graduate to a much, maybe some of the faintest stars that I can see through the binocular. And I'll get good focus on those. And you'll do that for each eyepiece. It's really helpful if you have a way to mount the binoculars. It's much easier to get that good focus. If you're trying to hold them up while you're doing it, it's much more difficult. Now, some binoculars have a center focus. So the focus is on the eyepieces. But if you have like a pair of birding binoculars, or those Skymasters behind me that are on the tripod, those have a center focus. So for those, you have a different procedure. So for those, what you're going to do is you're going to first focus and here's an example of that click stop eye guard. So if you're going to focus these, what you do is you first focus for your left eye. So you're only looking through your left eye and you're getting good focus on that. you can either close your right, or with a little training, you can learn to only pay attention to the left eye. So you focus for your, and it helps if you remove the objective. You focus for your left eye, and you get that as sharp as you can. Then you leave the center focus alone, and if you have a center focus, you're going to have a right diopter adjustment on just the right barrel. So, and it'll have like usually a little plus or minus sign on it. And you're going to then use that to adjust for your right eye, because a lot of times there's a little bit of difference between our left and our right eyes. So you'll get that one as sharp as you can. And again, sometimes I fiddle with this for several minutes, because critical focus will allow you to see fainter objects and resolve them better. Okay, so that is how you how you do your personal adjustments for your binoculars. The next trick is going to be to aim your binoculars. Like, how do you point them at what you want to look at? So I'll show you when I get to the mounting of binoculars. You can actually use things like red dot unit finders. You can actually mount those and basically use those. Because binoculars are fairly wide field, you don't really need a finder scope for most binoculars. But a red dot finder can be very, very helpful. And of course, you'll have to calibrate that each time you mount them to the binoculars. But if you're just hand-holding binoculars, which is one of the advantages of binoculars, again, portable, just take them out, got my neck strap on. What you do is you first sight the object that you want to see using your naked eye, if you can see it. I'm assuming for now that you can. And you look at that object, and then the trick is to bring the binocular, while you're still looking at the object, keep focus on the object, is bring the binocular up to your eyes. And the trick is not to move your head. And it takes a little bit of practice at first. Birders know this, but with a little practice, you can be very good at it. So you see a star, and you want to get it in your binoculars. So you look at the star, and don't move your head, don't move your head, don't move your head, don't move your head, don't move your head. Ah, there it is. And you might have to focus a little bit on it. So that's how you aim binoculars when they're not mounted. All right. Let's talk about mounting binoculars. If you mount your binoculars, having a steady view will sometimes allow you to see magnitudes deeper, like fainter stars, than if you're just hand-holding your binoculars. Most people cannot hold a binocular that is more than about 6 or 7 power, actually hold it steady. Now, Dwayne "The Rock" Johnson might be able to hold my 10 by 50 steady for a few minutes, maybe. I cannot hold a pair of 10 by 50 binoculars steady at all. There's always going to be a little bit of shake when I'm holding a heavy. This is a 4 to 5 pound pair of binoculars. It's got nice large prisms. These are heavy duty quality ones, but that comes with some weight. So you're trying to hold up. Your muscles are going to get tired, and you're going to get shake. Especially, again, if you're more than 6 or 7 power. So these are 10 power. So you need to steady them somehow. Now you can go full-blown tripod, or if you want to get really deluxe, the parallelogram mount. Sorry, that way. Which I'll show you in a second. But I found a really cool trick, and that is to use a monopod. So a mono means one, and there's only one leg on this monopod, and so it's got multiple. You can adjust it for length. So what I do is, this is really good if you're seated, as I am right now. So I am seated in a $8 camp chair that I got at Kroger or Walmart. And so I'm sitting in my comfortable chair. So I first adjust I'll adjust my monopod, for approximate length. And this one has a trigger grip ball head, so it's really nice. You can move it around, and then of course I'm going to have a plate where my binocular is mounted. And I don't have one already mounted, do I? Wait, yes I do. Aha! So here's one. It's already mounted. All I have to do is I'm screwing it in here to the socket on my binocular, and then again it's good to have an extra plate for this, and then I'm going to adjust the height, and I'll put the end of the monopod maybe between my feet to kind of steady it, and you can adjust the binoculars like this, and then you can lean back, and it takes a little bit of adjustment to get it just right, but then you can kind of, oh wow, that light is bright. Oh, that one is too. But you can lean back, you can adjust, and you can get a good bit of sky. And this does a couple things. It takes the weight. You're not carrying the full weight of these binoculars. And it eliminates most of the shake. You'll still get a little bit of lateral shake, but this really improves the view. And I guarantee if you get one of these monopods with the trigger grip ball head, you can get these from Overwork in Dayton, you will not regret it. This is it's a fun, really portable way to view without setting up a big heavy tripod or parallelogram mount. Now, there is another way if you don't want to set up those heavy things. You can use image stabilized binoculars. And I don't know whether Willkie talked about those or not, because I'm actually recording my presentation. Thank you. I'm recording this presentation before Willkie gave his. So just in case he didn't mention image stabilized binoculars, I happen to have a pair of Canon. These are 10 by 30 Canon image stabilized binoculars. These, you put batteries in them, and they have some fancy little mechanism that you press the button, and it's almost like magic. The view steadies. And now these are you still have to hold them, right? So you still have the weight issue. You don't have the shake issue if you're using the image stabilized, but you still have to hold them up. Now, some of these actually do have a tripod mount. I don't think these small ones do, but some of the larger ones do. In my opinion, that kind of defeats the purpose. If you're going to mount a binocular, you don't need the image stabilized. So I like these smaller pair of image stabilized, these like lightweight 10 by 30. I've heard the 10 by 42s are the top of the line and are incredible. They're a little pricey, so I don't have a pair yet. But these things are wonderful, and this is great if you have a zero gravity recliner, which I have, but I don't have room to set it up here. But you can just kind of lean back, and you can look around, and you have the advantage of a tripod and not too much weight. So I really like these. They're only 30 millimeter objectives, but so they're not going to see as deep as my 10 by 50 Fujinons, but these are a lot of fun. Okay, so let's talk about mounting binoculars if you want to get serious about it. And if you're going to use larger binoculars, say 15 power or higher, you're going to have to mount them. You just can't. You can't hold a giant pair. Even Dwayne "The Rock" Johnson can't hold a giant pair of binoculars steady. So you're going to have to mount them. You're going to need a really sturdy tripod, much sturdier than you think. So I'm going to walk back and show you some of those. I'm going to show you, first of all, a tripod that's not quite adequate. And then I'm going to show you the parallelogram mount. So Okay, hopefully you can still see me back here, and I'm going to speak up a little bit so you can hear me. So this is a tripod like you may or may not have at home. Some of the ones you have at home, probably you have to tighten them and loosen them each time you position them. That can be problematic for binoculars because you aim at something, and then by the time you've tightened it up, you're no longer looking at the thing that you originally aimed at. It's much better to have a smooth tilt and pan for binoculars. So this kind of mount is actually a good kind of mount, and this mount would be infinitely better than no mount. However, you see the legs are not very thick. This one also does not adjust very high. So if I want to look at something really high, one, it's going to hurt my neck because these are straight through viewing. All of the binoculars that I have are. When you get into some high-end large binoculars, it's really nice to have angled eyepieces so you're not looking straight through. However, one of the things I like about binoculars is that you are looking in the direction that you are seeing the object. And I kind of like that rather than looking down and then seeing something the light's been reflected. So this, you aim it. It's quite fluid and nice. The only thing is, this should be probably a taller tripod and a little sturdier, so that you don't get a shaky view. For the ultimate in binocular viewing, you have a parallelogram mount. So it's called a parallelogram mount because the apparatus here forms a parallelogram. You can see it better now. And the nice thing about these is that you have a counterweight that balances the weight of the binocular. So the binoculars are just basically floating weightless. And they have all sorts of range of motion. So some of these have 4 to 5 or 6 ways that they can move. And this can be done standing or seated. So I like to use a regular observing chair that has adjustable height. Some people, try to use these with the recliners, but then if you want to look at, that's fine if you're only looking at one little piece of the sky, but then if you want to look at something over here, you've got to get up and move your whole recliner. So I kind of like a chair that I can just kind of scoot around easily. So this one, you just kind of, you can just adjust it, and then you can look at, different parts of the sky. And I don't have to hold the binocular. And if you adjust if you're standing and you have people at different heights, in theory, if you just adjust the height of the binocular, so you would hold the parallelogram part and move it up or down, it will actually stay aimed on the object. So that's another advantage of using these. But these are they're a pain to set up, but they're wonderful once you do get them set up. And this one has a red dot finder on it. So I can actually, once I calibrate my red dot finder, if I point it at the part of the sky I want to look at or the object I could maybe see with my naked eye, then voila, it's in the field of view. So these are the ultimate, but again, you lose the advantage of portability. Okay. So there's lots of options for mounting binoculars, and I highly recommend that you mount them in some way, unless you have the image stabilized, or if you're just taking quick looks. So let's talk about some other kind of things. What can you do with binoculars? So Willkie may have already talked about some objects that are good for binoculars. One thing is star colors, because they actually make the colors look richer. And a lot of times your lower power binoculars will show the colors as more saturated because you're not spreading the light out as much. So if you have a 7x50 binocular, like these, older pair, they might actually show the colors a little bit better than a 10x50 would. So for star colors, I actually kind of like, or comets, to see the green color of a comet, that lower power binocular actually might be a little bit better. You know, binoculars are great for anything that requires a wide field, like planetary conjunctions, big open star clusters, you know, getting two galaxies like, you know, M81 and M82 in the field, large extended objects like the Andromeda Galaxy. These are all great binocular subjects. With the larger binoculars like that, you can actually see some pretty small objects like the Ring Nebula. Now, you're not going to see it as a ring, but you can actually see a little bit of the greenish blue color, and you can see that it's a non-stellar object. And I've had a lot of fun spotting some planetary nebulae using those Fujinons in from a dark sky. There are some observing programs that are designed just for binoculars. So, for example, the Astronomical League that has, like, for example, your Messier observing program, they have a list that's designed just for use with varying size binoculars. Now, it's a reduced list, so instead of 110 objects, you might have 70 objects that you have to check off. But that's a good challenge to look at them through binoculars. The AAVSO, so the Variable Star Observing Organization, has a binocular, they have a list of variable stars that you can observe using binoculars of various magnifications. So finally, I wanted to show some, I've already showed you some star atlas. I wanted to show you a few binocular books that are observing guides or other references for binocular use. So the first one, this is a great one for beginners. This one by Gary Saronic, who is one of Sky and Telescope's veteran binocular observers. He wrote this book called Binocular Highlights, and it's just a list of good binocular objects, and they're kind of arranged by the season of the year that you can see them. And it'll show you a typical, you know, maybe 5 to 6 degree binocular field, and give you enough context to look at it. So this is a good thing. If you've got a pair of binoculars and you're like, what can I see? This is a good one. Along the same lines, this is an older book by Sir Patrick Moore, the late Sir Patrick Moore. And I love reading his books because he's got this dry wit and humor that's just a lot of fun. Philip Harrington, who is the author of this other fine book, this is Starware. Now this, I wish they would come out with another edition of this, because this tells you, like, gives you the scoop on all the great astronomy equipment. Unfortunately, even the 4th edition, I don't know if there's a newer one. This is quite dated, but it has a lot of information particular to binoculars, so it's still worth checking out. But he also has an observing guide, and you'll see the pair of binoculars on the front there. Those are the Fujinon 16x70s, and there's a reason that these are just some of the best binoculars for astronomy without paying 3 to 4 times the price. There are observing guides, especially for observing the moon. This one is a little older, by Charrington, but again, a lot of stuff a lot of detail you can see on the moon. This is a fine little book by Firefly. It's actually a lot of really good information in there about choosing and using binoculars. Probably, if I had to buy just one book on binoculars, I would buy this one by Stephen Tonkin. So this one is called Binocular Astronomy. If you buy his book, he has a newsletter that you get a free subscription to, and each month he actually has binocular highlights, and they're actually designed for people who live in Great Britain, not the United States, but we're close enough latitude that unless it's something like an occultation of a star or something like that, his list of things to observe will be quite useful. And finally, this might be my favorite book for learning about astronomy, period. Not just for binocular astronomy, but Craig Crossan, he has this book, and he basically teaches you about the Milky Way and and stellar formation and all kinds of useful real astronomy. But he does it in a very interesting way. So you're exploring the sky, but you're also learning some real astronomy. And then it has some of Will Tirion's maps in the back. So it's actually got includes a star chart with the book. So this book, there's a second edition. This is the first edition. Is a wonderful one to have. So that's basically what I have on using binoculars. Again, if you just want to be done and have the ultimate astronomy binoculars, my recommendation would be to get the Fujinon 10x50s because they have a really nice wide 6.5 degree field of view. They have field flatteners, so the view is almost flat to the edge. They're rugged and durable. These can last longer than you will last, probably, if you take care of them. And they'll give you many, many, many nights of binocular observing fun. So thank you, and I believe that we'll be able to take questions when we present the program. Thank you, and have a good night.